All right. Well, at this point in Unit 5, we have seen how to classify polynomials as well as the 4 basic operations, so how to add, subtract, multiply, and divide. That really leaves us with 2 more things that we're going to talk about for polynomials, one of which is solving, the other is graphing. So this section as well as the next will deal primarily with solving polynomials, and then we'll see how that connects with their graphs. So with solving, a lot of the same properties of solving still apply from quadratics, with a few exceptions and a few additions that we'll talk about today. So the main thing that stays the same is we're still going to use the zero product property. So just as a warm-up, let's take a look and remember how the zero product property works. Remember that if you have 2 things being multiplied which equal 0, neither one or both must equal 0. So when we have something like x minus 2 multiplied by x plus 3 being equal to 0, then what we do to solve is we set both of those equal to 0, so x minus 2 equals 0, and also x plus 3 equals 0. And then once we've done that, we just solve both of those equations for x, which is pretty simple, and we end up with answers which are the opposite of our 2 factors, so x equals 2 and x equals negative 3. All right, let's do that on number 2 as well. Now this time we actually have 1, 2, 3 factors. So for the first one, we set 3x equal to 0. For the next, we set x plus 7 equal to 0. And for the final one, we have x minus 1 equals 0. So then solving each of those for x, the first one we divide by 3 on both sides and get x equals 0. The next we subtract 7, so x equals a negative 7. And for the last, we add 1, so x equals a positive 1. Now, number 3, here's where we can talk about why it's important to not just take the opposite and try to say that x equals 5, which is not true of our first factor. So it's always best to continue to set them equal to 0. That just helps to minimize mistakes. Because in truth, what's going to happen as we solve for x in our first equation is it's not x equals 5, but 3x equals 5. And it turns out x is going to be a fraction. X is going to be equal to 5/3. For the second equation, it is true that x does equal the opposite of our factor, so x does equal positive 9. So be very careful, especially when the variable has a number in front of it. Okay. So before we get to solving, we're just going to focus primarily on the factoring, because really then to solve, it's just a matter of using zero product property, and we'll see some examples of that as well. All right, so in these next few examples, we're going to look to factor. As a hint, we are always going to make sure to look for a GCF first. So for our first example, for example A, we've got x cubed minus 5x squared minus 6x. The greatest common factor here is that they all have x in common. So we're going to factor out an x. That's going to leave us with x squared minus 5x minus 6. And now here's where we continue to look to try to factor. So looking at our numbers inside our parentheses, we're looking for numbers that multiply to be negative 6, add to be negative 5, and those 2 numbers are going to be negative 6 and positive 1. So that would be x minus 6 and x plus 1. And then we just have the x that was factored out in front. Now, again, later on, we'll solve and really remember all that solving means is we're going to take each of those factors and set them equal to 0. But for right now, we're just going to focus on the factoring. All right. So for example B, 3x cubed minus 27x. Here our GCF is 3x. So let's factor that out. When we do so, we get x squared minus 9 inside the parentheses. So continuing to factor with x squared minus 9, it turns out that that is a special type. Remember that that is a difference of squares. So that's x plus 3 and x minus 3. And then we just copy down our 3x that was in front. And then there is our factoring. All right. For example C, we've got 3x cubed plus 9x squared minus 162. So as we're looking to factor this, the only thing that we could probably do is note that they are all divisible by 3. So that would be 3, and then in parentheses, x cubed plus 3x squared minus 54. However, at this point, there's really not a whole lot else that we can do to continue to factor. So really at this point, we would be done. Now, obviously that's not ideal. Obviously you want to try to always get it down to linear factors if possible. But at this point, there's no other way to factor, so we're just going to be done. All right. For example D, x to the fourth minus 9x squared plus 14. What we're going to do to factor this is we're going to kind of do it the same way that we would x squared minus 9x plus 14. In other words, we're going to look for numbers that multiply to be 14 that also add to be negative 9. And as far as numbers that multiply to be 14, those should be pretty quick. 7 and 2 are probably going to make the most sense. And to get negative 9, negative 7, and negative 2. So as we set up our two factors, we'll have negative 7 and negative 2. Now, if we try to just say x and x for our variables, then unfortunately we're not going to get back to our original expression, because obviously taking x multiplied by x is x squared and not x to the fourth. So instead of using just x, what we're going to do is we're just going to use x squared. That way when we take x squared and multiply by x squared, we do in fact get x to the fourth and the rest of the expression as well. Now, at this point, until we have linear factors, we would normally check to see if we could continue factoring. In both cases, the only way that we would be able to continue factoring is if this was a difference of squares, and neither 7 nor 2 are, in fact, perfect squares. So actually, at this point, we would be done with factoring. Okay. So, for the most part, that factoring is the same as what we saw when we were solving quadratics, with the exception being that we found a GCF first, and with D, we kind of did a little bit of a different factoring there as well. This next type of factoring is brand new to us. So this is an example of factoring by grouping. We're going to take a look at a few examples of that, and then look at the special cases. Now, in order to factor by grouping, the first thing that you have to have is you're looking for where you have 4 terms. Anytime you have 4 terms, that's your clue to try to factor by grouping. So when you factor by grouping, what you'll do is you will basically split your expression in half. And so you're going to have 2 terms kind of to the left of where I drew the line and 2 terms to the right. And what you're going to try to do is you're going to try to factor out a GCF for both of your terms. So on the left side, between x cubed and 6x squared, the GCF is x squared. And that leaves us with x plus 6 inside the parentheses. For the right side, negative 5x minus 30, our GCF there is 5, and it would probably work best to factor out a negative 5, and that also leaves us with x plus 6 inside the parentheses. So now, the way factoring by grouping works is you want for these 2 parentheses to be the same. And if they are, what we're going to do is we're going to factor out an x plus 6 from both of our terms as well. I'm going to go ahead and cross those off to say that we factored it out. And what we're left with is this x squared and this minus 5. That's going to become our second set of parentheses, our second factor. Now, at this point, looking at our 2 factors, x squared minus 5, we would normally look to continue factoring. However, 5 is not a perfect square, so it's not a difference of squares. So actually, at this point, we would be done. Let's take a look at a couple more examples of this. So in the next one, we've got x cubed plus 4x squared plus 2x plus 8. We're going to start the same way. Remember, there are 4 terms, so split them in half, 2 on each side. So on the left side, we've got x cubed plus 4x squared. The GCF there is x squared. That leaves us with x plus 4 inside the parentheses. On the right side, we've got 2x plus 8. GCF on that side is a positive 2. And also gives us x plus 4 inside the parentheses. So once again, our parentheses match up. We're going to go ahead and factor those out first. And then what's left we'll put into another set of parentheses, so x squared plus 2. And again, with x squared plus 2, it is not a difference, so can't use difference of squares. So at this point, we would be done. Okay. For our last one here, for G, let's continue to work through this. So x cubed minus x squared we would say x squared would be our GCF. When we factor that out, we're going to get x minus 1 inside the parentheses. On the right side, our GCF is a positive 2, so factor that out. But we get x plus 1 inside the parentheses. So notice that now our parentheses do not match up. And even if you tried to use maybe a minus 2 on the right side, that's going to give you a negative x minus 1 when you factor it out, and your parentheses still don't match up. So for g, we're just going to have to say that this is not factorable. Now, not factorable is not the same as not solvable. This equation is still solvable, we're just not going to be able to do it by factoring. We're going to have to use some other method, which is what we'll talk more about in the next section, actually. But for right now, we're just going to say it's not factorable. We'll worry about solving tomorrow. All right, so now let's talk about some special cases. Remember that really our special cases for quadratic were the difference of squares. So now we're going to look at both the sum and difference of cubes. So we have difference of cubes. We also have the sum of cubes. Now before we get going too far, let's talk about our perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and we'll continue to fill these in. So let me fill those in real quick, and that way we've got them ready to use. And we'll go up to 10 cubed, which is 1,000. Probably won't need to go much higher than that today. All right, so with sum and difference, we have these two formulas. Very, very similar in the way that they are set up, but make sure that you're using the correct one. Now, if you're wanting a way to try to memorize these, and again, you're not required to, but we use this acronym for them called SOAP. And so what that stands for is the first sign in your factors is always the same. So plus and plus, minus and minus. The second sign is always the opposite. So that's plus and minus are opposites, minus and plus are opposites. And then the AP stands for always positive. The last sign in your factors are always positive. Now, the rest of it, you'd have to remember kind of the setup with A's and B's. But if you're wanting a way to remember at least the signs for those, then SOAP, that acronym, is just an easy way to remember that. Okay, so let's go ahead and look at a few examples. For this first example, for example A, we've got x cubed plus 8. So we are going to be using the sum of cubes formula, which is actually right above it. Now, in order to do that, we need to know what A and B are. In other words, we need to know what is being cubed to get to x cubed and to get to 8. For the variable, it's usually pretty easy. Obviously, x is what's being cubed to get x cubed. For 8, we can take a look at our perfect cubes. 8 is the number 2 cubed, so 2 is what is being cubed to get to the number 8. In other words, A is going to be x, B is going to be 2. So as we plug those in, our first parentheses is going to be a plus b, so that's x plus 2. Our second parentheses is going to be a squared, so x squared, minus a multiplied by b, so that's x multiplied by 2. But we would probably want to write that as 2x, and then plus b squared, so plus 4. Now, at this point, we are actually done factoring. Now, normally you would want to try to factor this x squared minus 2x plus 4. So look for numbers that multiply to be 4 that also add to be negative 2. Unfortunately, there are not any numbers that multiply to be 4 and add to be negative 2. In fact, this part of the expression is never going to factor. So just as a hint and a way to save some time, you're going to have to find another way to solve besides factoring for that second expression. Okay, let's take a look at a difference now of cubes. So similar to A, we've got x cubed, which comes from x being cubed. For 343, that is the number 7 that's being cubed. So A is going to be x, B is going to be 7. Notice that b is not negative 7. All that the minus sign entails is that we're using our difference formula instead of our sum formula. So don't worry about it as a negative 343. Only treat it as a 343 in order to use these formulas. Okay. So in putting those into our formula, we're going to start with a minus b, so that's x minus 7. The second parentheses is going to be a squared, so x squared, plus ab, so that would be plus 7x, and then plus b squared, so plus 49. And again, at this point, we're done factoring. Even if it's tempting to want to look at that second parentheses to see if it'll factor, remember that that will never be the case. Okay. For this last one for C, a little bit different. For the variable, we still have x being cubed to get x cubed, but we also need to look at both the 8 and the 125. 8 we've seen before, that is the number 2 cubed. 125, that ends up being 5 cubed. So it turns out a is going to be 2x, b is going to be 125, or b is going to be 5. So putting those into our formula, remember we're going to start with a plus b, so that's 2x plus 5. Our second parentheses is going to be a squared. It's important to remember that for a squared, that's going to be the entire expression 2x squared. And so when you take 2x and square it, you're going to get 4x squared. So that's going to be our second parentheses. It's going to start with 4x squared. Next, we'll have a minus ab, so 2x multiplied by 5 is a minus 10x, plus b squared is 25, and then there is our second factor. So really the key, if there is a number in front of x cubed, make sure you know what number is being cubed to get that, and then make sure that when you're putting that into your formula for factoring, that that first term in the second parentheses that I've got underlined, super important to make sure that that comes out correct. Okay, so that's the basics of factoring. We're now ready to do some solving, and I would encourage you to continue throughout the rest of this video to watch. Obviously now you've seen all the different factoring and really would just have one more step to go, but there are some special cases with solving, so let's make sure that you're good to go before you start to try to work on the homework. Okay, so taking a look at this first example, we've got x cubed minus 6x squared minus 27x. So we're going to look to factor first and start by factoring out our GCF, which is x. That's going to be x squared minus 6x minus 27. That's left inside the parentheses. So now we're going to look to factor what's left inside. So numbers that multiply to be negative 27, that add to be negative 6. And those two numbers are going to be x minus 9 and x plus 3. Don't forget to bring down the x that was in front. And now we do have it as an equation, so we do need to have the equals 0 at the end. At this point, it's time to go ahead and solve. So for the first factor, you set x equal to 0, and in fact, that's already one solution. For the next, you set x minus 9 equal to 0, and so to solve, just add by 9. And for the third factor, x plus 3 equals 0, so subtract 3, and you'll get that x is equal to negative 3. Okay, let's take a look at number 2. So on number 2, we've got x cubed equals 25x. So in order to solve this, it would be kind of tempting to want to just divide by x on both sides, because you divide by x and you get it to where it says x squared is equal to 25. And then that seems pretty easy to try to solve. And in fact, that would get you a couple of solutions. But we're going to see why dividing by x and in general, dividing by a variable is never a good idea. Instead, let's go ahead and try to get this to look like we did on number 1. So let's get one side of our equation to equal 0. So I'm going to do that by subtracting 25x from both sides. So my left side now is x cubed minus 25x. Next, we'll go ahead and factor out our variable x, so that'll give us x squared minus 25 inside the parentheses is equal to 0. Now we're going to try to continue factoring, and x squared minus 25 is in fact a difference of squares, so we can use that special type of factoring, which is going to give us x plus 5 and x minus 5. Don't forget the x in front and the equals 0 at the end. So now setting each of our factors equal to 0. For the first one, we get x equal to 0, and that one's already been solved. There's the reason why we couldn't divide by x before. If we did try to divide by x, remember that would technically be dividing by 0, and remember you are not ever allowed to divide by 0. And so in any case where you could divide by a variable on both sides, do not ever divide by that variable because you're dividing by 0. Now, had you divided by 0, you would still get your other two solutions, because x plus 5 equals 0 leads us to say that x is equal to negative 5, and x minus 5 is equal to 0 does in fact lead us to x equals 5. So you would have gotten those two solutions had you incorrectly divided by x on both sides. However, you would have been missing that first solution, which is crucial as well. All right. Moving ahead now, let's go ahead and take a look at number 3 next. So we've got negative 3x squared plus 28x is equal to x cubed. So once again, while we could try to divide by a variable on both sides and divide by x, we just saw number 2 that is not the way we're going to want to work this. Instead, we want to get one side to equal 0. So let me just subtract x cubed from both sides. So that would be negative x cubed minus 3x squared plus 28x is now equal to 0. So now, looking for GCF, on the left side, we are going to be able to factor out an x. To make things easy, what I'm going to go ahead and do is factor out a negative x. Because what that's going to give me is it's going to give me a positive x squared inside the parentheses, and that's going to be a lot easier to work with than a negative x squared. So now be careful with your signs on your other two terms as well. Negative 3x squared is going to be a positive 3x, and positive 28x is going to be a minus 28. So make sure that you are changing those signs because of dividing by a negative with our GCFX. So now what's left inside the parentheses, let's go ahead and continue trying to factor that. Numbers that multiply to be negative 28 that add to be positive 3 would probably want to be x plus 7 and x minus 4. Don't forget the negative x in front and the equals 0 at the end. Okay, so now setting each of those equal to 0, when I have negative x equal to 0, divide by negative 1 or multiply by negative 1 on both sides, and you're still going to get a 0. So in fact, x is going to be equal to 0. For our next factor, x plus 7 equals 0, we solve that to be x equals negative 7. And for the third factor, for x minus 4 equals 0, we solve that to be x equals 4. All right. So for number 4, we're going to factor this very similar to a problem we saw before. We're going to factor it very similar to what we did for example D here on the first page. In other words, we're going to try to factor it like normal and just use x squared as our variable instead of just x. So in other words, we're going to look for numbers that multiply to be negative 6 and add to be negative 5. Those two numbers should be x minus 6 and x plus 1. And remember, since it was x to the 4th power, we're going to say x squared minus 6 and x squared plus 1. Now, at this point, we're going to continue to try to factor. Unfortunately, in both cases, we don't have a difference of squares, so we are actually done factoring. That does not mean that we're done solving. So to solve, we are going to still take each of our factors and set them equal to 0, but we're going to have to finish solving them some other way besides factoring. We're going to have to use some of those skills that we picked up in Unit 4 with solving quadratics to finish working this problem. In fact, the easiest way is probably just going to be to solve by square root. So for our first equation, add 6 to both sides to be x squared equals 6. And then take the square root on both sides, so x equals the square root of 6. And then don't forget your plus and minus sign. Doing something similar on your second equation, we would start by subtracting 1 from both sides, then taking our square root. So we would have x is equal to the square root of negative 1. Again, don't forget plus and minus. And then remember that the square root of 1 is the complex number I. So our other two solutions are going to be complex. We're going to have x equals positive I and x equals negative I. All right. Let's take a look at a couple more examples, and then we should be all set. So number 5, x cubed minus x squared is equal to negative 2x minus 2. First thing we're going to want to do is have one side of our equation equal to 0. So let's go ahead and add over the 2x and add over the positive 2 from our right side of the equation, and now we've got it equal to 0. So now, to decide what type of factoring to use, notice that you've got 4 terms. Remember, 4 terms means we're going to try to factor by grouping. So, looking at our first group of terms, x cubed minus x squared, we can factor out x squared. Gives us x minus 1 inside the parentheses. For our second group of terms, if we factor out our GCF, which is a positive 2, then we get x plus 1 inside the parentheses. So unfortunately, our two factors are not equal to each other inside the parentheses, which means that we are not going to be able to factor. So this problem is not factorable, but it is still solvable. Now, we're not going to actually be able to solve it today. So for today, we're just going to save it as not factorable. But in our next video, we'll talk about how to solve an equation like number 5, and we'll talk about it then. So for today, we're just going to say not factorable. And again, remember, not factorable does not mean that it's not solvable. Okay, so our last problem that we're going to look at is going to be on number 6. We've got 2x cubed minus 16 is equal to 0. So first thing we're going to want to do is factor out a GCF of 2. And that'll give us x cubed minus 8 is equal to 0 for the rest of our equation. Now, unlike on number 2 for our examples where we would not divide by a variable, it is okay to divide by a number. Remember, it wasn't okay to divide by the variable because we didn't want to divide by 0. But in this problem, if you want to go ahead and divide both sides by 2, that would be okay. On the left side now, we'd have x cubed minus 8. On the right side, 0 divided by 2 is just 0. Okay, so with x cubed minus 8, now we've got a special type of factoring where both are perfect cubes. X cubed is obviously the variable x being cubed, and 8 is the number 2 being cubed. It is a minus 8, so that'll tell us to use our difference formula as we are factoring. So for the difference formula, we're going to take a minus b, so x minus 2. And then our second parentheses, we're going to take a squared, which is x squared, plus ab, so that would be x multiplied by 2, which is 2x, plus b squared, so plus 4. All of that being equal to 0. Now, remember that the second factor, so x squared plus 2x plus 4, is not factorable. So at this point, we need to go ahead and try to solve. We're going to go ahead and set each of these equal to 0. So that's the x minus 2 is equal to 0, and then x squared plus 2x plus 4 is equal to 0. Now, the first equation is pretty easy, in fact, to solve. Just add 2 to both sides, and you get x equals 2. The second equation, however, is not going to be quite as easy to solve. Obviously, we've already said it's not solvable by factoring, and this is not one that we can solve by square roots because we do have a middle term. Remember that leaves us with 2 options to pick from. We can either use quadratic formula, or we can do completing the square. Now, this is set up for completing the square, so I'm going to go ahead and solve it that way. If you'd prefer to use quadratic formula, you'll still get the same answers working it that way as well. So it's really up to you how you want to solve. So with completing the square, what we're going to do is we're going to go ahead and write our equation down, x squared plus 2x, but we're going to put a plus blank after our x squared plus 2x because we need to figure out what number that needs to be in order to complete the square. We'll go ahead and put the plus 4 is equal to, and on the right side, we'll also put a blank. That way we remember to add by the same thing on both sides. Now, in this case, our b value is 2. So b over 2 is 2 over 2, which is 1. And so if you take b over 2 and square it, which remember is what you're going to need to do to figure out what number goes into those blanks, then that's going to be the number 1 squared, which is just 1. In other words, we need to add by 1 on both sides of our equation. Okay, so we've completed the square. Now it's just time to rewrite it. So our x squared plus 2x plus 1 that I've got underlined for us there, that's going to factor to be x plus b over 2, so x plus 1 squared. Don't forget we have the plus 4 after it, and don't forget the 1 that we added to the right side. All right, so now in order to finish solving, it's really just a matter of solving by square roots now that we've completed the square. So we're going to start by subtracting 4 from both sides, so x plus 1 squared is equal to negative 3. Then we'll go ahead and take square root of both sides, so don't forget plus and minus sign, square root of negative 3, which we'll simplify in just a moment. Let's just go ahead and get x by itself first, so subtract 1 from both sides, so x equals negative 1 plus and minus the square root of negative 3. And then to simplify that, 3 obviously you can't take the square root of, but since it is a negative 3, we do want to bring the complex number I out from under the radical. So that would be negative 1 plus and minus I multiplied by the square root of 3. All right, guys, that is it for this video. In the next video, we're going to look at how to solve those problems where they were not factorable, but I mentioned that they were still solvable. Until then, have a great rest of your day.